Hi everyone, today in Integrated Math 1, we're going to go over Chapter 7, Lesson 2. Here are the objectives. Make sure you write them down in your notes. Alright, so we have a couple things that we need to see. So when we have the same bases being divided by, so notice we have 2 to the power 7 being divided by 2 to the power 4. Notice they do have the same base. What's going on here is that they're going to be reduced. So every single time here that we can reduce them, we're going to reduce them. So that's the real idea I want you guys to be thinking about here. So notice one set was canceled, another set was canceled, and then another set, and then the final set, because we can't go any farther because there's none on the denominator. Then we have 1, 2, and 3, 2 to the power of 3. Which is left, and that's the same idea here, which is going to make more sense for the quotient of powers. To divide two powers with the same base, we want to subtract the exponents. So c to the 11th power divided by c to the 8th power. They have the same base. That's the first thing we need to check. Then we can subtract the powers. C to 11 minus 8 is c to the 3rd. So if we go back, you're going to say here 2 to the 7 minus 4 is 2 to the 3rd. And that's where this comes in handy. But we don't necessarily want to do this every time. This is a simpler way to do it. So power of a quotient. To find the power of a quotient, find the power of the numerator and the power of the denominator. So notice here is like the distributive property again for the numerator and the denominator. So 3/5 to the power of 4 is equal to 3 to the power of 4 divided by 5 to the power of 4. Oh, but one thing you want to keep in mind is your denominator cannot be equal to 0. It will not work. So then we have the zero exponent property. Any non-zero number raised to the 0 power is equal to 1. 5 to the 0 power is equal to 1. B divided by C to the 0 power property. B divided by C to the 0 property is 1. Anything is to the power of 1. Anything to the power of 0 is 1. Then we have the negative exponent property. For any non-zero number, a and the integer n, so a to the negative n power, is the reciprocal of a to the n. Also, the reciprocal of a to the negative n power is a to the n. So we have 2 to the negative 4th power, put it over 1, and now this becomes positive, and we can simplify it from there. Alright, so let's go over example 3. We want to simplify 2k to the 4th power times m to the 3rd power divided by 4k to the 2nd power divided by m. And we're going to assume nothing in the denominator equals 0. So let's get our like terms together. 2 to the 4th, those are like terms. Then we have k to the 4th divided by k to the 2nd. Then we have m cubed divided by m. Let's put a 1 there for us. And let's simplify this. Well, 2/4, that's 1/2. And then we have k to the 4th divided by k squared. Well, there's a division sign there. 4 minus 2. Same thing here. And let's keep on simplifying this. So we have 1/2 k squared m squared. And there we go. Well, if you want to make it look a little better, you can say k squared m squared divided by 2. There we go. Alright, so let's try this next example. Simplify t to the 4th u v to the negative 2 divided by t to the negative third u to the 7th. Let's get the t's together. T 4 divided by t to the negative 3 u to the first power divided by u to the 7th. And there's only one v, so v to the negative 2. You can put that over 1 if you need it. So notice, remember, we all have the division signs underneath it. So we can do this. So t 4 minus negative 3. This is where you have to be very careful. You could have switched it to the positive 3 over here, but I'm going to show it to you this way. u1 minus 7, and then v minus 2. We're going to change your signs. T to the 9th power, and u to the negative 6, v to the negative 2. I cannot leave my answer with a negative exponent. So t to the 9th is good, but with the denominator, so I'm going to put this to the side. U to the negative 6, the way we can change it is 1 divided by u to the positive 6th power. Same with v to the negative 2 power. It's 1 divided by v to the positive square power. So u to the 6th and v to the 2nd power. Notice this just has a 1 in front of it. And there we go.